we talked about the idea of sampling. We talked about how this whole realm of statistics involves taking samples from a big population, right? So the population is the big thing, the sample is like the small thing that represents the population. And hopefully we can get like a really good representation of our population by selecting a good sample. And the way we go about that is using these things called sampling techniques. The simplest kind is random sampling, right? So we talked about how you can just use a random number generator to get a random number, and that will give you like the person in your sample. The second type isn't as like basic as the random sample. It was called the stratified random sample. And is there anyone who can help me remember what stratified random sampling was about, or what kind of went into doing that? Nico.
You basically put people into large categories, such as with their age or race, and then you pick a small portion of people from each category and sample them.
Perfect, right? So the idea behind stratified random sampling is you have groups of people, like Nico said, like age or race or something, they all share some sort of similar quality. And you're basically taking parts of each of those categories and putting them into your sample so that every single one of those categories are represented in the sample. And they're also represented by like their percentages, right? So if you have 40% freshmen in your population, you're going to have 40% freshmen in your sample, right? So that's the whole idea behind stratified random sampling. And we did a couple examples of those. Oh, we also talked about cluster sampling. I totally forgot we did that last class. In cluster sampling, we also have groups of people, but in this case, the groups of people don't share a certain quality, right? So they aren't all the same age. They don't all have the same hair color, for example. They're all different within each of those categories. And what's also different about cluster sampling is we're not taking something from each sample. We're just selecting like two, or we're not taking something from each category. We're just selecting two of the categories and sampling every single person inside each of those categories. And then some of the other categories we don't sample at all. All right. Any questions on cluster sampling? All right. Melanie, do you have the notes from last time? All right. Perfect. All right. Now, I didn't go through this example because we kind of ran out of time. But in this example, I'm going to say this is cluster sampling. This is something that the government does a lot. And the reason they do it is because it's very convenient for them. For example, if the government wanted to know the unemployment rate in the country, for example, what they would do is they would go to a random sample of households in the country. So they'll just choose certain households. They'll go into each of those houses and ask every single person in each house that they selected the same question. Okay, and they'll ask them, oh, are you employed? Are you unemployed? Okay. Anyone want to guess like what the clusters are in the sample? Cassidy?
The houses?
The houses, right? Because, well, each of the houses house a group of people. Now, they might not all be the same type of people. There are different types of people within each household, but the houses themselves are the clusters. And if you even want to visualize it, you can think of each of the clusters as houses. There are people in each of the houses. And what the government will do is they'll go into a neighborhood and select maybe like one house. And every single person in that one house, or your cluster, so each of these are clusters, right? Every single person in the cluster that is selected gets put in the sample. All the other houses get ignored, basically. Okay. Any questions on cluster sampling? All right. Okay, let's go to, I think this is our last sampling type. The last sampling type is called systematic sampling, okay? Now, this sampling method is literally described in the name. In systematic sampling, the word system is in it. So there's some sort of system that we use to generate the sample, okay? Now, you're probably wondering, like, the other ones were systems. This one is like a very obviously a system, and let me kind of explain it to you, okay? When we have systematic sampling, we have people in our population or things in our population, and they can all be different, right? We can have circles, we can have squares, we can have stars, triangles, I don't know. I think you said Diamonds. Yeah, I like diamonds. Here you got stars and stuff like that, right? And what we're going to do is we're going to order the population in a way that we can give every single person a number. So maybe there's like a first person and a second person and a third person, fourth, fifth, sixth, seventh, eighth, nine. Okay. So systematic sampling is really useful when like you can order things in a line. Maybe like people walking into a classroom, for example, or an assembly line of things like on a belt being processed, right? So whenever we have something that you can line them up and assign numbers to every single person, that's when systematic sampling is good. So this is our population. The way we go about our sample is what you'll do is you'll choose something like, okay, I'm gonna choose the second person, okay? That's gonna go in my sample. Then what you're gonna do is be like, okay, every third person after that is going to be in my sample. So if the second person got sampled, they'll do 1, 2, 3. My fifth person gets sampled. 1, 2, 3. Oh, did I do that right? My eighth person gets sampled. And then you'll keep going. And every third person or every fourth person or every second person gets put in the sample. So there's a very clear system as to like who goes in the sample, right? So every third, every fourth, every fifth. Okay. Now, if you go up to the definition, it says like items are ordered and every eighth item is chosen. The term A just means any single number. Okay. So in our example, every not third, but third item was chosen to be in the sample. Any questions on what systematic sampling is? All right, I think we're doing pretty good. Let's do a little bit of a more like real life example of systematic sampling. So this is kind of how systematic sampling happens in real life. For example, you have automobiles, so like cars coming on an assembly line, people are working on them. And what you really want to do is you want to check the steering system. Now, they don't want to check every single car in the whole place. So what they're going to do is they're going to start with the third car, and every single fifth car after that is going to be in the sample. Okay. So it basically is asking us which car is in the sample. I don't really do well with doing this in my head. I think it takes a little bit more time for me. So whenever I do something like this, I just draw a picture of what's going on. Okay. So we got cars in our assembly line. I'm not good at drawing cars. Yeah, make them squares. Squares are good, right? Those are easy to draw. All right, so we got, I'm going to draw a bunch of them. Let's just pretend they're on this assembly line. I'm going to draw a lot of them. And let's just pretend, since I don't have enough space, they're just going to go down here as well. Okay, I think that's enough. All right, now with systematic sampling, remember, we have to assign every single car a number because they're in a line and we can figure out like where they are based on where in the line they are. So I'm just going to number them based on where they are in the line. Okay, let's say we have like 18 cars in the line. Okay, it says the starting point will be the third car and then every fifth car after that will be sampled. What's the first car going into my sample? The third car, right? Because it says, well, start with the third car, right? So this one's definitely going in my sample. Okay, then it says every fifth car after that will be sampled. So what do you think the next car is going to be? Let's see, I'm actually not good at doing this in my head. I have to draw the arrow. 1, 2, 3, 4, 5. Perfect. The eighth car is going to be sampled, right? And then what's the next one after that? 13. Perfect, right? Because you go 1, 2, 3, 4, 5. Perfect. And then let's do one more. What's the next car after that? Yeah, I think it'd be 18, right? Because you'll count 1, 2, 3, 4, 5. The 18th car will be sampled. All right. Yeah, it's not too bad, right? All you have to do is just count every fifth one after the third car. Now, I think the picture does help a little bit in doing this. If I had to do this in my head, I don't know if I'd be able to do it. So I think drawing our picture will help us a lot here. Any questions on systematic sampling? All right, I think we're pretty good. So in general, we have a couple of types of sampling, right? We have random sampling, stratified, which have the groups, right? We have cluster sampling, and then we have systematic sampling. Now, I used to just teach this and then move on, but I got a lot of questions the past couple semesters of like the difference between them. And I have 3 questions that I think have been always asked to me, and I feel like it's just better to have it on our notes instead of having you ask me right before the test. So what I'm gonna do here is, how about this? Why don't you find a partner? Okay, so find someone close to you, maybe a group of 3 or group of 2. I want you to discuss these 3 questions. Okay, so the difference between stratified versus cluster. Which one would be more, or when would something be more beneficial, and then what do you think is the best type of sampling? Why don't you discuss this for about, I don't know, 5 minutes, and then we'll come back as a class. How are we doing on time? Doing good? All right. Yeah, I heard some really good discussion. Really nice job talking about this. Some of these questions don't really have like a right answer, but I do think the first question has a correct answer. So is there any like group or person in a group who wants to describe the difference between stratified random sampling and cluster sampling? I see Lauren, yeah.
We talked about how stratified random sampling more has a pattern to it, and it's not very random most times because it's always like the same thing.
I like that idea, right? Because, well, stratified random sampling, the people in the, or how the groups are like designed have a pattern to it, right? It seems like every single group share a certain quality, right? I really like that. So why don't we write that out? So stratified random sampling. It has a pattern, or maybe every single group like shares a quality, right? So every group shares, oh my gosh, someone is writing on that chalkboard real hard. Shares a quality, right? And that's not the case in cluster, right? Because in cluster, the groups have people that all are different, right? They don't share anything except that they're in the same group. Any other differences between stratified and cluster sampling? In stratified random sampling, every group gets put in a sample, right? At least someone from each group gets put in the sample. Is that the same in cluster sampling?
No, I think 2 get chosen.
Yeah, right. In cluster sampling, like I'm gonna choose like 3 or 2 or 1 group, and then all the other groups don't get put in the sample. Now that doesn't happen with stratified random sampling either, right? So maybe I'll say in cluster, some of the groups get left behind, right? We don't take some of those groups. So some of the groups get left behind, as opposed to stratified random sampling where, well, at least there's going to be someone in each group that's going to be put in, right? So oh gosh, I don't know how to write this. I'm going to say someone from each group gets into the sample. All right. Any other differences between stratified and cluster? All right, I think that's kind of sums it up. I did see some good explanations as I was watching your discussion there. I do think this is the difference between stratified and cluster. I get this question a lot because they're so similar, right? We have 2 types of sampling where groups are a big part of it, but the way that we go about doing the sampling within the groups are a little bit different. All right, any question between the difference between stratified and cluster sampling? All right, then we go into number 2. We have a question. When does stratified random sampling become like more beneficial than cluster sampling? Any ideas here? Gabriella?
When you're trying to like sample from like every being, like you really get results from everything. It's like just like one group.
Yeah, right, when you have different groups and you wanna like make sure all the groups are represented, right? For example, if you have a bunch of different age groups, you don't wanna accidentally take a bunch of like really old people when there's a bunch of really young people in the group, right? So how would I write this? When there are different types of people that you want to represent, I think that makes sense. Different types / groups of people that you want to represent. How about that? Any other ideas on when stratify would be better? All right, I saw your hands up. Is that what you're gonna say?
I think it is more beneficial when we're gonna get more accurate answer or an accurate response versus.
Oh, that's a good idea, right? I do think stratified random sampling, it might be a little bit more accurate than cluster sampling. And why is that?
Because you can make sure you're getting every single demographic that's available, even if it's just a small section of it.
Yeah, right. So to put that into perspective, if the government wants to estimate the unemployment rate and they go to one house, is that one house going to tell how the whole world is unemployed, right? That's not going to be a good representation of the population. So I do think that stratified might be a little bit more accurate. So let me just write that out. Stratified equals more accurate. And I'll put a question mark. The reason I'm putting a question mark is because, well, cluster sampling sometimes is used and is somewhat accurate. So I can't always say that stratified is more accurate than cluster, but thinking about how it goes about, it does seem like it would be more accurate, right? Okay. Number 3, what do you think is the best type of sampling and why? Any ideas on this one? Can't be a wrong one here.
I like the cluster.
Yeah, you like cluster. Who said I'm not gonna put random in here because I think random's kind of basic. Who thinks stratified is the best? All right, see some hands. Cluster. All right. And systematic. The systematic. No one said systematic. I do. There's a time and place for each of these types of sampling. Of course, some of them are easier than others to do. For example, the government would probably always use cluster sampling because they want to go to people's houses, right? I would kind of agree. I like stratified. That's just my opinion. If you like the other ones, you're not wrong or anything, but I'm gonna put Amy stratified. And the reason I like stratified is because, well, in a lot of cases, we do have lots of groups of people, especially in this day and age, like we have these groups of people who share different qualities. And I do like it when each of those groups are like represented in a sample. So that's why I say stratified. That's not the right answer though. All right, any questions on our discussion? All right, that was pretty good. That's all I have for sampling, and I think we might want to start our next set of notes today. So before I go on, is there anyone who has questions about sampling? All right, so we're going to talk about, instead of just sampling, we're also going to talk about things that can go wrong when we do sampling and things that can go wrong after we've done sampling. And that kind of gets lumped in this idea of this word called bias, which we'll talk about a little bit later. Okay, so when we do data, or when we work with data, or when we deal with statistics, there's kind of 3 important steps that we go about with doing things like this, okay? The first thing we do is we usually go out and collect data, right? We talked about sampling, all the things that you do when you take a sample from a population. Collecting data is a big part of data and statistics, okay? After you collect data, you have to display it. So a lot of times you go on the news and you're expressed with data, you're not usually given like a big chart of the data, but you usually see like a graph or something like that that kind of displays the data so it's easy to look at. The third thing that you do is what we'll do most of the semester, summarizing data, where you do a bunch of mathematical things to come up with numbers that represent the data. Like, for example, we'll talk about the mean next week, I think. Okay, so what we're going to do right now is the fun part of figuring out things that are wrong. We're going to focus on displaying data for a little bit. So we're going away from the sampling part and going into the graphs and things like that. Okay, now, no matter what you do in life, most jobs require you to work with data. They especially require you to display data. And even if you don't have a job where you work with data, or you don't have a job at all, you're actually constantly shown data. You're shown this display of data. You see charts all the time, especially in this day and age where we have like technology and things like that. You're always given graphs, and sometimes the graphs might not show the data accurately. So what we're going to do is we're going to look at a couple of these graphs, and we're going to figure out like what's wrong with them. Okay, so my first graph here, I have two graphs. They both show interest rates. Okay, one of them seems to go up, one of them's kind of flat. And what if I told you that, well, these two graphs represent the same data? So the same data are represented with these two graphs. Does anyone know how one can go up and one of them just stays the same? Oh, here you go.
It's because of the y-axis. In the first one, it's very much more trying to show the small differences between each number. Whereas in the second one, it's just showing like the giant numbers. It's only focusing on the whole number instead of the decimal places.
Good. So like you're like, okay, well, the spacing between the numbers on the y-axis or the vertical axis, they're a lot bigger on the right-hand graph, and they're a lot smaller on the left-hand graph. How did they go about doing that? How they make the left-hand graph smaller and the other one bigger? Cassidy?
The right one goes up by 0.5%, and then the left one goes up by like 0.002%.
Yeah, right. And how did they fit? Like, how do they fit differently? Gabriella?
They start at so the right start at 0. And then
Yeah, right. If you look at the graph, like on the right, it starts at 0, right? And most graphs do start at 0, but they don't have to, right? The graph on the left starts at 3.14, which is pi, by the way. And that's how they were able to fit like such smaller increments on the y-axis on the left-hand side instead of the right-hand side. Okay, so graphs don't have to start at 0, and these graphs aren't necessarily wrong, but they display things in a different way to make you think something different, right? On the left, you can think, wow, the interest rates are increasing like skyrocketing, right? And on the right, if you look at it, oh, the interest rates are kind of about the same. Okay, so the way that you're represented, or that you're shown data a lot, can be really misleading if you don't look into like what exactly is going on the graph. All right, let's take a look at this next graph. This one's a little bit harder. Okay, on the left, we have annual revenue. It seems like it's going up. On the right, it looks like it's going down. And the same thing, these two graphs represent the same data. Now, how can one be going up and how can one be going down? Look carefully. Does anyone see why? What is it? What's your idea?
It looks like on the right hand side of the graph starts like around that number 3.
Like what, 300 million, yeah. I will say they do start at the same spot.
One's cumulative and the other is not.
Oh, so you took a look at the title, right? One of them says the word cumulative and the other one doesn't, right? Does anyone know what cumulative means?
General, like.
General, yeah.
General, like, content, something. It's like, I heard of cumulative GPA.
Cumulative GPA is a big one, yeah. Has anyone heard of a cumulative exam? Yeah, so like if you take a cumulative exam, like for example, I am required to give you a cumulative final exam. Test 1, test 2, and test 3 are just tests based on what we learned recently, right? The cumulative exam will take everything from test 1, everything from test 2, and everything from test 3 and combine them all together, right? So for example, this is kind of, it's easier for me to explain by drawing this out. Let's say in January you make, I don't know, $3. Let's say, well, that's not much, but whatever. Let's say in February you make $4, and let's say in March you make $2, and in April you make, I don't know, $5. Okay, so this is your data. Okay, let me show you what cumulative data would actually mean. So let's put cumulative. Okay, so cumulative data in January would be 3. What would the cumulative score in February be? 7, right? Because you're going to take 3, which is what you had previously, and add on what happened in February, right? What would be the cumulative data for March? 9, good, because you do 7 plus 2. And what would it be for April? 14, right? 9 plus 5, right? So the idea of this word cumulative is you take everything from before and add it up and include like wherever you're at, okay? So can a cumulative graph ever go down?
Not really,
No, right? Unless you have like negative values, cumulative graphs have to go up, right? So there's no way a cumulative graph can actually go down. So what people will do, like if you're presenting something for a business and the annual revenue is actually going down, what you could do is you can make a graph of the cumulative annual revenue, and it looks a lot nicer than the annual revenue, right? Even though the company's actually not doing very well, you can make it kind of seem like the company's doing all right.
Wait, so is that how they like trick, but not trick like others?
Yeah, this is a
Yeah, my company's going this way. So
Yes.
they use the cumulative one to make it seem like everything's all cool and stuff.
Yep, that's how they do it. I think I heard there's this phrase, like there's lies, there's white lies, and then there's statistics. So yeah, data can be hugely deceptive, and especially when you see these graphs like in real life, like when you're scrolling on your phone, for example, things might not be as they look. All right, let's go on another one. Okay, here is a little bit more morbid. We have a graph of the gun deaths in Florida. So looks like the gun deaths are actually kind of going down recently. Can anyone see anything wrong with this? Nico?
It's number of murders committed using firearms instead of like overall gun related deaths in Florida.
That's true, but there's actually something like even more deceptive in this graph. I'm gonna tell you, oh, do you see it?
The zeros at the top, so it starts with the largest number at the bottom.
Yeah, like look at the y-axis, right? Usually the graphs, like the zeros at the bottom, they put 0 at the top, okay? So instead of this graph like going up, it's actually like flipped upside down. So if you want to look at this graph and you want to see if what the gun deaths are doing, you actually have to flip this graph upside down to see exactly what's going on. So what's actually happening to the gun deaths? Are they going down?
Very little. It like, it goes up and then like in more, like in the 2010s, it starts to.
Okay.
721.
Yeah, like it's going down here, even though it's going up. So whenever the graph is going up, it's actually going down. But more recently, it does look like the deaths are actually going up, okay? So this graph was created to make it look like after this law, the gun deaths were actually going down. After the law, the gun deaths were actually going up. So it's very deceptive, and it takes a while to kind of even look at what's going on. But this graph is literally just flipped upside down. So it looks like it's presenting something different. Okay. Any questions so far? All right. Let's look at another one. And this one's kind of a famous example. This is something called, that we'll go to a little bit later. It's called bivariate data, where we have two graphs kind of put on top of each other to see if there's this thing called a correlation or connection between the two graphs. So it looks like between these two graphs, the number of people who drowned by falling into a pool is in red. And it does look like the films that Nick Cage has been in seem to correlate or follow the red graph. So looking at it, you might automatically be like, oh, thanks, Nick Cage. Thanks, you're making people drown by falling into a pool, right? But there's actually no relation between these two, right? Even though it looks like it is, there's no relation. Does anyone know like what the phrase is that kind of encapsulates this idea? I think a lot of people say it in like high school. It starts with a C. Yeah, causation, right? So I did the idea of correlation. So correlation, which we'll talk about. Oh my gosh, I can't spell. Oh my gosh, correlation, which we will talk about a little bit later in this class. We always say it doesn't equal causation. Okay, so just because two things follow each other or look like they have a relationship, that doesn't mean that one of them causes the other. Okay, so there might not be any relationship, they just seem to follow the same trend. All right, let's go to the next graph. This one is kind of interesting because it's very deceptive. This one is showing the air temperature change in Celsius. And if you look at this graph, it does seem like the air temperature change is going down. There is this like red line here. Does anyone remember from high school maybe like what this line is called? It has like a very special name. That might be what it's called in biology, but it's called a line of something. We'll talk about this later. Yeah. Yeah, perfect. This red line is called the line of best fit. And we'll learn about this a little bit later. We'll learn how to create this line. We basically take all the data and we take a line that seems to represent how it's going, right? Sometimes it's called a trend line because we want to see if the graph is really going up or going down. What's wrong with this graph and the line of best fit?
It's just switched around or something.
Why?
It's on this side, the y-axis.
That's true. The y-axis is on the right side. There's something a little bit more deceptive here.
Is the line of best fit like a little bit crooked?
Yeah, is that what you're gonna say? Yeah, the line of best fit doesn't even seem like it fits the data, right? It doesn't look like they did anything to the data to figure out what that line is. Doesn't it look like the graph, if we ignore the red line, the graph does look like it's going up, right? But someone put a red line on top of this graph that just goes down. It's not the line of best fit, it's actually a fake line of best fit, right? It just seems to be going down, even though the graph is actually going up. So, ooh, I like that. Let's do that. The line of terrible fit. Yeah, so someone literally just took this graph, they put this fake red line on top of it and was like, cool, this is the air temperature change in Celsius. Now, below it says the source is NASA. I do not think that NASA would make this. I think they do a little bit more math when they create these graphs. But I think that one's the funniest one out of all of these. Okay, so I think a lot of old people are still on Facebook, so they see a lot of this and they kind of just come up with, oh my gosh, I saw this graph and it looks like it's going up and it looks like it's going down. But we have to be a little bit more careful when we look at graphs because a lot of the times they're presented in a way that is completely different than what the data actually shows. All right. Any questions before we kind of move on from our graphs? All right. Now those were kind of fun. I'm not going to give you a graph on a test and be like, what's wrong with the graph? These take a little bit of work to figure out what's actually going on. Okay, but this kind of does segue into the topic. We talked about how there can be deception in graphs. There's also deceptions when we do surveying. So when we take a sample, when we ask people questions, there's a lot of deceptions that go into that as well. So let's just pretend that we're designing a survey. Like I want to ask a bunch of people a bunch of questions. What are the types of questions that I can ask? Like what are examples of questions that can be asked in a survey?
Like, yes, no questions, like. open ended.
Oh, those are actually two types of them that I want to talk about. So like yes, no. We call those types of questions binary questions because there's only two types of answers. Another idea of like a binary one would be like true or false, right? And then Gabrielle also said there's open-ended questions, right? So open-ended, like free response, something like that. All right, any other types of questions that can be asked?
Preferences.
Oh, like preferences, yeah. So I like that. So maybe like a word, right? So preferences. Any other ideas?
Like how likely, dislikely.
Yeah, I like that. That's more like a scale, right? So like on a scale of 1 to 10, like how likely would you be to do this? So I like that idea. How likely? This is more of a scale, right? I guess one other thing I can think of is maybe like numbers, right? So like how old are you? That would be a number that you would answer with, right? So like age or a number. Okay, so there's honestly a lot of different types of questions that you can get as data, right? And we'll talk about how to categorize those a little bit later. But there's also, in addition to the different types of questions we can ask, there's also different ways that we can ask the questions. How can I go about like giving out a survey? What are methods I can use? Oh, Gabrielle?
Like, mail.
Mail, right? You get mailed surveys a lot, right? So mail, what else? Email is a good one, right? I get a lot of email surveys. I actually got a survey the other day that sent me like a $50 Amazon gift card, which is kind of cool. Cassidy?
In social media. Was it you?
Ooh, huh?
Was it from you?
No, it was from like Macmillan Learning. It was like a textbook site. Did you get something from you?
Yeah, I got something from you. It was like $50 something.
Oh my
I didn't do
gosh.
that. It was too much.
Yeah, some of those surveys are like way too big.
Yeah.
Yeah, it's not worth the gift card. I saw,
Yeah, like pop-ups on those sites.
oh yeah, like anything on the internet, right? So websites, internet. All right, any other ideas? In person, good, right? That's that happens a lot, right? In person. Any other ideas? I don't know. I guess I can think of one. I get phone calls a lot, right? I usually don't answer them, but I do get phone calls. Okay, so there are a lot of different ways that we can answer or that we can ask questions, especially like to people and things like that. We do have to be a little bit careful though when we ask questions, and we'll talk about why that can be a problem. And we also have to be careful in how I ask the questions, right? For example, not everyone has a phone, right? So we have to think about what goes on when we go about surveying something or go about surveying in a way that might exclude people or might be asked in a different type of way. And because of all this, all these different options that we have, there's this thing called bias, okay? I have the definition up here. I do think it's a good way of describing what bias is. We call something bias when we go about gathering some information. So when we go out and sample a bunch of people, if the way we do that makes it like more likely to get some more response that isn't the actual response, that's when something's biased, okay? So when it's more likely that the sample doesn't represent the population, that's when we call something as a biased sample, okay? Any question on what bias is? Okay, Just like sampling techniques, there are types of bias as well. We're going to talk about 3 of them. We might just talk about the first one today. Okay, let's just talk about types of bias. Okay, our first one comes about when we use this sampling type called a voluntary response. Okay? Literally in the name, a voluntary response is when we ask someone to volunteer their response. This is used a lot like in the media. I think this happened a lot when radio was a big thing. They would go and ask a bunch of people to respond to the radio and give their opinion on like what the station should play or something like that. Okay, so voluntary response is when we ask someone to respond to a sample. Now, what problems do you think can come about when we do this type of sampling? Without reading the next bullet point. Great.
Not be able to do it.
Yeah, not everyone will be able to do it. Now, that kind of is a different result than what I'm looking for, but that is something that can happen. That can really mess up. Actually, you know what? Let me bounce off of that. What types of people wouldn't want to respond?
Like shy people, they're not gonna call them to read.
Yeah, shy people would definitely not do that. How about this? What if I asked you, or asked the school, what do you think about this restaurant? What do you think? Give me your response about how this restaurant is. What type of people do you think would respond? Or did you have that?
I was gonna have a different thought. I was gonna say like employed somewhere, like people are major like response because like a job or something like that.
Oh. That's also a good idea, right? You don't want to like slander your name, right? Let me try to ask a question that's more on the spot. Let's say I wanted to get an opinion on a business. Okay, do you think people that just feel mediocre about the business is going to respond? Yeah, usually when you ask someone, oh, give me your response about a business, for example, like Yelp and things like that, that ask for an opinion on how a business is run, usually the people that respond are the people who are like, I hate this business. This business is the worst. I wish it went away. Let's cancel the business, right? That's the main response that I expect. The other main response that I expect are people who are like really, really, really into the business, that really, really like it. So for example, if we ask like, how do you like this restaurant? You'll probably get people who are like, this restaurant is great, or this restaurant is awful. But you're not gonna get people who are like, yeah, the restaurant's all right. I don't care. Most of those people aren't gonna respond, right? So when we have voluntary response samples, we're kind of missing out the middle ground of people. You get the high extreme thought, usually the negative ones, because people with negative opinions tend to respond a little bit more often than people with positive opinions. But you definitely don't get the people in the middle, okay? So voluntary response bias happens when you get people with really extreme opinions, but you don't get people in the middle who have like mediocre opinions, okay? So the way I would think of voluntary response is you get the extremes. So extreme opinions, but not the mediocre ones. Okay, does that kind of make sense? Exactly, yeah. Yeah. All right, I think we're out of time, so I'm gonna let you go. We'll pick up on the types of bias